Today in the Android class, I'm going to do the second part of Chapter 7, and the problem with this is this involves using a deliberately vulnerable app called Civ, and this is why you may have noticed I don't use any of these deliberately vulnerable apps in this class. I use real apps because they're always written very badly, and I've always had the same problem with them, which is they only install on really particular old versions of junk. So this is unfortunately no exception. It does demonstrate some esoteric vulnerabilities, which I haven't found in any real apps, and therefore I wonder how important they really are, but I would like to demonstrate them, and I will attempt to do that, although it is very hard to set up, and I'm not sure how well my demonstrations are going to work. So, we're up to attacking application components, and that's for next time. So, now, one big issue here is intents. You can send an intent from one Android app to another, which is a signal to request service from another. It's like a remote procedure call in Windows, or for that matter, Linux. And so if an app has a login screen and you don't want another app being able to log in, you'd have to develop your own authentication mechanisms to limit who's allowed to reach there. So Civ is this app to install on an emulator. Now I cannot get it to install on any emulator at all on the Mac ARM. And the only way I know to get it to install on anything is to use the Genymotion emulator for 32 bits on x86 and then add the ARM translation library. So let me see if I can show you that. I was able to get it working, but it is kind of ridiculous. So I should have a remote session open. Okay, so here I am on a Microsoft machine, and there should be a Microsoft Start menu down there, which I can't seem to get to very well. All right, and so this is Microsoft Windows. Now it's a 64-bit operating system, but what I did was install Genymotion. Now, I discovered today another horrible thing. Genymotion is now disabling networking for free accounts, although on Windows, it seems like the version still lets you have it. So anyway, I had to make an Android 7 32-bit device. And let me just point out how to do that if you don't know. You add a virtual device, you choose any form factor, it doesn't matter. And here, you choose Android 7. And x86. That gets you to a 32-bit device, not a 64-bit Intel. That's what you do. And then just the default for everything else. I'm not going to bother making a new one. I've got one here, so I've got one of them running. And once you've got it running, you want to install this thing called Civ. Now let me see if I can close enough tabs to get back to the instructions here. All right, yeah, here we are. So really, this lecture is essentially a demo of this 511. So Civ, you can download here. It's an APK, which is an Android file, but it's very particular. And when you try to install it on that emulator, it will reject it and say no ABI is found. And that is the install will fail because it's an ARM app, but you're on an x86 emulator. The cure is to add ARM translation libraries. Now, for old versions of Android, I know how this works. These ARM translation libraries emulate ARM on x86, and they're available, but they're only available for versions of Android up to 9. And there are some weird documents online that claim that Android 11 includes this, but it doesn't seem to be true. I cannot seem to install any ARM apps on Android 11. So as far as I know, the only way to make this work is to use old versions. And when I went back to 7, it worked. So I downloaded this Genymotion ARM translation for 7. You download the zip file, you drag the zip file onto the emulator, and it will automatically install. It's reflashing the emulator. And so, I don't know what this garbage is. Anyway, all right, so it will just, then you have to reboot the machine, and then you can run ARM apps on this. You'll be able to run this thing called Civ, which should be here if I can drag this thing up, which I seem to be unable to do. This happens to some of my students too. Double click, maybe this one. And this old version of Android, you click that one to see them. There should be an app called Civ, and there it is. Good, so I can drag it and drop it on the desktop for easy access. So I've got it going. Now, the point of this thing is it's a password manager, and it is, of course, the world's most terrible password manager. That is the point. We're going to look at the vulnerabilities of it. All right. So we're going to enter, we're going to start it and put in a password and a PIN to get it started. All right. And then we're going to see the first flaw in this app. So let me get back to my Windows on Intel machine. Okay, here we are. So I launch Civ, and the first time it's going to ask me to specify a password to use. So I'm going to put in p@ssw0rd. I think I have to put in like 16 digits. Yep, it demands 16 digits out of some impression that would be more secure, which it isn't, because this thing is not very secure. So 1, 2, 3, 4, 5, 6, 7, 8. Now another one. p@ssw0rd, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I put in a password to initiate the password manager. That's the master password. Password cannot contain special characters. Well, that's the kind of thing you get. We'll just try password. 1, 2, 3, 4, 5, 6, 7, 8. And password, that's a pretty common clue. 2, 3, 4, 5, 6, 7, 8, that you're dealing with people that don't know what they're doing when they have rules like that. Anyway, now we need a PIN, which I'll make 1, 2, 3, 4. 1, 2, 3, 4. Submit. Okay, now I'm ready to use the thing, and I think I have to sign in with my password, which is password 1, 2, 3, 4, 5, 6, 7, 8. Sign in. Oh, I must have got it wrong. All right, let me try again. Password 1, 2, 3, 4, 5, 6, 7, 8. Sign in. Okay, now I can put passwords in here. All right. Now the first thing is you should be able to see the settings app before login. So let's see if I can duplicate that. If I stop this app, if I click this, it'll show me the running apps, and I can drag it and drop it. Okay, I said drag it and drop it. Well, normally you can drag and drop. Maybe under these conditions, my drag and drop is just not going to work well enough. All right, I'll try restarting the, wait, I can kill it in settings. That's what I can do. Let's find settings. This is, now I'm not getting any response at all. Oh, there, okay, I'm getting some kind of slow response. All right, click this thing to see all the apps, okay. Then there should be settings, there they are. Let's drag settings so I can reach them more conveniently. There it is, okay. Now in settings, I can kill an app. Since I can't seem to do it from the square, which is the kind of thing that tends to happen. Settings, home. Apps, there we are, apps. And it's going to wireless instead of going to apps. Boy, I'm having pretty bad experience with this device. Settings. I'm somewhere stupid. Let's try searching for apps, see if that's going to work. I think what's going on is it's so slow that it's replying to clicks I make much later when I'm no longer pointing to the right thing. So here's apps. There we go. Now there's Civ. I should be able to stop it from here. However, apparently not. All right, unable to do anything else, I'm going to just stop the phone and restart it. I can't figure out any other way to stop an app on this thing. It's not working very well. All right, let's see if I can restart the phone. And if that stops the app. I was afraid I'd have problems. All right. It's coming up bigger. That's interesting. It's Genymotion. All right. This is the right one. Okay. So it shouldn't be running any apps right now. And it is not. Just settings, which is not very important. All right. So the point here is when you launch Civ, you can enter the settings without logging in. So here I am. It needs me to log in. But before I log in, I can get to settings. This is a fairly common mistake. And in the settings, I can change the pin. And I don't need, let's check my, now it looks to me like I would need to know the old pin. Let's see what it says here. Settings is available before login. You could go in here and you could in principle change the pin, although it looks like I would have to know the old pin, so it's not as bad as I thought, but it looks like I could delete passwords or back up to an SD card, and those might expose things. So anyway, this is one flaw you have when the logic of your app lets you get to something important before the login. And this is easier to do than you might think, as we're going to see. That was an obvious one where there's an option right there. But let's take a look at the exported components. Now, if I run Android Studio here on this Mac, it could run it on anything, and it'll run better on the Mac than in this remote desktop session. All right, now I've got this central pane where I can examine apps, and I'd like to close this old one. There we go. Now I can put Civ on there. I've already got it downloaded here. There's Civ. So I drag it into the middle. I can examine this app. We've done this before, and it's really quite handy. And now we can take a look at the Android manifest. And the Android manifest contains a lot of useful information, and in particular, it contains all the pages you can see, the activities. So here's something called .pw list. Here's settings. That's the one we were just in, I think. Here's something called add entry, short login, welcome, pin, auth service, crypto service, and so on. Let me go to my slides and see what I want to point out here. All right, there's something called a file select activity, which is exported. Exported means it's visible to other apps on the device. And there's two other exported activities, main login and PW list. So if we look here, let's find file backup is exported. Looks like a lot of things are exported here. Oh, well, those are providers. Okay, if we go to activities, all right, these are not exported. Okay, this one's exported, PW list, which is probably bad. That means you can open some password list from another app or directly into here without passing through the login screen and such. And here's the main login activity, which is apparently not exported, but the file select activity is. All right, so you can see what's exported there. That's one thing worth seeing. All right, and so there they are. These can be started from any app. There are unexported activities. Now, even if you don't export an activity, you can still launch it if you are root on the Android device. This is why secure apps generally do root detection and refuse to run on root devices, although many, many apps do not do that check. So we can launch these things from an ADB shell. So let's give it a try. We could, with that command, we should be able to launch, say, the file select activity. So let me see if I can get that to work. All right. Now I'm going to need ADB, and I've installed Android Studio on this PC. Let me see if I can make sure the SDK is on here. I try to get to the start buttons for the Windows, which is down there. Okay. And then Android Studio, good. Well, I think I'm going to have to install it, but that's not bad. There's something should be there. Okay, here we go. Yes. Okay, good. I don't really need all of Android Studio, but what I want is ADB, and this will include it. Now, what's this? I think I've already approved that. Installer could not request. But I think this one is still running. Okay. This happens a lot on Windows machines and other machines that are really slow. You click things, you click them again, and then multiple launches come in later. All right. Next. Finish. All right. Do not import any settings. Don't Send junk somewhere. Okay. Welcome. I don't care about your welcome. Standard whatever is fine. I don't care about any of this. And accept. I think I have to accept a bunch of things. All right, there we go. And, okay, it's got to download some junk, okay. Well, this may be too slow to wait for. All right, I will skip ahead and come back to that if it ever finishes. Anyway, if you gig a shell on the device, you can use the AM command to launch an activity directly. You have to give it the full path to the activity. This is the path to the app. Then you give it a dot slash, and then a dot, and then a slash, and then the name of the activity. And for some reason, the name of the activity starts with dot here. So that'll launch the particular activity. If you have an unexported activity, it won't launch unless you root. And that'll show you a page in the app. All right, now there are content providers. Let me just check and see if there are comments in the Twitch. Cannot set up locally, you have disabled that. Genymotion has been running very slow. I'm using Microsoft Virtual Machine. No, I'm using a real Microsoft machine on real hardware. You can't run any Android emulators on a virtual machine because they have to have direct access to the graphics card. So I've got a real Windows machine here with remote desktop turned on, and I'm connecting from the Mac. And all right, so now the content providers are another issue. Content providers are databases, essentially. They're available, and it's not explicitly marked exported equals false, but it would be exported if I had a really old version of Android, like Android 4, which I don't. I've got Android 7. There are two providers, DB content provider and file backup content provider, but they are both exported. You'll see them, exported equals true and exported equals true. And let me, by the way, resize this so it doesn't go outside the part of the screen that is being broadcast. All right, so, all right, they are, and there are no permissions required, except notice there is a path permission for keys. It has /keys here, where if you have a path including this string, or a path equal to this string, which we're going to talk about, then you need to have these SIB permissions, read keys and write keys, to use it. That is going to turn out to be a mistake, as we're going to see. So you can find the paths to objects by using JADX. I don't think I can try to demonstrate this with all the problems I'm having, but JADX is a tool that will reverse engineer the APK into Java, and you can then search through it, and we'll be using it in the projects. And you can look for content. And when you do, you'll find these paths to objects that are referred to by paths, starting with content. These refer to parts inside the app. And this is quite useful. You know, there's something here called keys, something here called passwords. Those are useful things to know about. And so you can do a query, once you know that path, with a command called content query. And you don't need to be root to do it. Then you just give the path of the thing you're trying to see. And this will expose a username and email. So let me go to my project instructions where you can see the results of this more. Since my demo, I think, is pretty hosed. Let me see if this thing ever moved, this installation. All right, looks like, nope, it's just started some download and it's not moving. All right, I think my ability to demonstrate anything on that Windows machine is basically shot. So I'm gonna just have to talk about, use the canned screenshots for now, and hope I can get it working in some later class. So let me get 511. It is a little project, we'll be doing it later. I'm going to have to add a lot of extra instructions here to tell people how to get this done on modern machines if I can figure out how to get it to work on anything. I think I can get it to work on Windows machines, maybe never on Macs. Anyway, so, all right, so you can put passwords in Civ, we've done this, and a PIN, all right. And when you sign in, you can enter a password, which is going to go into the password manager. And then, I see we look at the Android manifest file, which we just did. And whoops, okay, I didn't go down there, so I'll get out of screen at a time. All right. All right. And we talked about these activities that are exported. All right, so to exploit a published activity, all you need to do is execute this AM command on the Android system, and you do that by preceding it with ADB shell. So this will launch that activity, but only if it's exported. And so the password list page will open looking like this, showing your saved passwords. Now, here's the content providers. We talked about these, DB and file backup. Now, JADX requires Java, and then you can run JADX, and then you can do a search through the source code. Like I say, it's the thing developers don't understand about Android apps is that you basically have the source code with them, and you can get the Java commands, including these content URLs. So now that you know the content URIs that point to things, you can view them. And so here's the query that will open this thing called passwords. And it will show a username and email address, but the password was an encrypted blob. And there it is, it just puts blob here. In earlier versions, it would actually show me a long blob of base 64, but here it just shows me an encrypted blob there. So, all right, now you can view something called keys here, but it will tell you you don't have permission to see them. You need to have this specific permission, which is one defined by this app, read keys. We talked about this before. You can have standard permissions like access the network and access the pictures, and you can define permissions specific to your app, which is what's happened here. You need to have this SID permission, read keys, to do it. But the problem is we've used keys here, and because that matched the description in the Android manifest, here, it required this permission. But what we can do is read the instructions. If you use an Android path permission, then it means the exact path must match what you give here. So the path has to be exactly /keys and nothing else. Therefore, all you have to do is put another slash at the end, and now it will not match the path anymore, and that permission will not take effect, and you can then see the password. It is pretty dangerous. What you wanted was a different path option that would match any part of the path containing the word keys, but that's not what was there. So that's another flaw inside the structure of your apps. And then there's SQL injection, which is good fun on here. This is how you send data in for SQL injection. You do a query to another one of these content providers, and then you feed in an apostrophe. Now this is the equivalent, the most familiar kind of SQL injection. You'd have a parameter up here in a URL, like file equals foo, and you put an apostrophe there in a parameter. This is how you normally exploit a SQL injection. You put an apostrophe in a parameter, and then it will cause a syntax error, because that apostrophe will match an apostrophe the developer put there and cause the wrong number of apostrophes to be there. And this is the equivalent for Android. You insert an apostrophe in quotes. And because you see a no closing quote error here, that proves the same thing a SQL syntax error does in web apps. It proves that it misunderstood this apostrophe as matching an apostrophe put there by the developer, and therefore the code is confusing data that came from the user with instructions put there by the developer. And that's the fundamental code injection flaw that is at the heart of SQL injection. So all you have to do is put in a carefully crafted projection, and here's the one, star from SQLite master where type equals table, semicolon, dash dash. So this executes a complete SQL command, jumping everything out of a table, and these terminate it so it doesn't worry about unmatched data at the end. And therefore, you will now dump out the contents of a table, and it will show you name is passwords and key. It shows you the names of the tables. And this is the same process in all the other SQL injection. First, you get the names of databases. We don't need to do that here because the content provider is only one. We need the name of tables, and then we need the name of fields. And here you see, here's the structure. Password, text, primary key, pin text. This is telling you what tables exist and what their structure is. So now you can tell it to me star from passwords. Now I know there's a table named passwords, and now we will see the passwords, although it shows an encrypted blob. Anyway, that's the sort of thing. It's pretty clumsy, but it shows the flaws that you'd expect to see in a web app in this Android app. Now let me go check for comments in the Twitch. No new ones, all right. And let me go back to my slides. That's what I wanted to show you, and I was hoping to demonstrate more of it, but my equipment is totally not working. So, all right. All right, sending an apostrophe breaks the syntax, and then you find table names this way because you dump from the master table the names of all the tables and the structure of the tables, and then you can dump the contents from a table. So here's what happens if you dump the key table. You get the password and the PIN to log into the app, and if you dump the passwords table, you see this stuff, and in the later, all right, it shows you a blob for a password, but at least you get the names of the users. But since you have the login for the main password manager anyway, you could just log in and steal the stuff. So there have been other ones with flaws like this. Samsung devices had a vulnerability exposing all these things, SMSs, emails, passwords, and so on, and this shouldn't be too much of a surprise because we covered earlier there was an app vulnerability where you would have a file explorer on your phone, and it would just serve all those files with FTP with no password to anybody on your network. So these kind of flaws happen pretty often. And that was again because they had a content provider that did not require permissions, and it also had a SQL injection. This is extremely common. Also happened to Amazon. All their databases in their Amazon buckets were open to the world by default for many years. And so many, many people put their data up there without realizing the whole world could see it. So, all right, you can have a content provider, which might let you allow other apps to retrieve files from it. If you do accept requests from other apps, you should treat them as untrusted and validate them before you use them. So when you get a request to open a file, you should validate it against an allow list of allowed files or folders. You should not try to just remove bad characters because there's ways to sneak them in. Otherwise, they'll be able to accept files. This is called local file inclusion. They'd be able to refer to other files on the Android system that they're not really supposed to see. And this is exactly analogous to the same flaw in web apps and APIs. Then that's local file inclusion. Civ does have this vulnerability. You can do a content read, and then you can field file backup provider and put in system, etc. hosts, and you'll see the hosts file, which is the IP addresses matching to domain names. And it's not an important file, but it shows that you are able to move out and see a system file, which is not what you intended to display with this functionality. And here's the /keys path we've talked about. And here's the Android documentation explaining path permissions. So you could have path pattern or path prefix. Either of those would have worked better, but path means you have to match the entire path. And therefore, just adding a slash to the end means you no longer match. And that's the problem. So now, if you try to dump the keys here, you don't have the right permission. If you do a request ending in keys, but if you end in keys /, you get the secrets. So this is another gotcha, where it's another error the developer made, but this is a pretty easy error to make, to use path instead of path prefix is the fundamental error here. All right, let me take a look at the comments here. Okay, no new comments. All right, so then there are services. The services run in the background, just like they do in Linux and Windows, and provide services to these things. You can launch them with an intent, and an app can bind to a service. Then it can send messages to the service, and the service could do any of a lot of things. So there's an onStart command method in your service. They'll receive it from apps, and again, your service is receiving requests from apps, and you cannot trust that because the apps might be malicious. So again, you'll have to see if the request can exploit it in some way, and there doesn't seem to be a general way to test for that. You just have to read the code to assess the risk. In 2012, there was a clipboard save service that would copy files from one location to another. You could put a file on a clipboard and move it, and therefore a package with no permissions could install another package by copying it to a certain location. Now, unexported services can only be started by their owner, but by that app. But if you have root, you can launch them even if they're not exported, using start service and stop service, just like other app components. Now, bound services are ones you use to remote procedure calls, where one app will request service from another app, and they implement the onBind method and return this structure called an iBinder. That's the remote procedure call mechanism whereby one app can request service from another app. So you can extend the binder class, or you can use a messenger and send message objects to each other. These are various internal Android ways for one app to request service from another app. And you can use this thing called Android Interface Description Language, which makes methods in an app available to other apps. And it's more complex and rarely used. So if you want to see if it's vulnerable, you're going to have to look at the code that receives these messages and then see if it does insecure things with the message, like use it to evaluate a system command. So Civ has two services, auth service and crypto service. And if you look at the source code in JADX, you will see another common vulnerability, hard-coded parameters. There's a code 2534 and a code 6345 and a couple more codes down here, all hard-coded. So these are special codes that have special privileges for key and for pin. This is very common that developers put secrets in the source code, which is a really bad idea when I can see your source code. So you can request the password from another app if you can guess the pin, but you could brute force it, then you get the password. And all right, and there are broadcast receivers. These are listening to requests from other apps. And so here's your workflow. Your app takes login credentials, verifies them with a server on the internet. If they're correct, it will send a broadcast telling the app your credentials are okay. Now, the app will receive the broadcast with an intent filter. And so here's a broadcast, a receiver, it's exported, and it's listening for correct creds. This is the kind of workflow that has happened many times. For example, all right, well, let me finish this and I'll talk about many cases where this happened. So any app could just send the intent. Even though you didn't log in and it didn't verify your credentials, it could just send this intent telling the app that your credentials were correct. And therefore, you'd be logged in. This has happened many times. It happened to the San Francisco parking meters that Joe Grand proved about 10 years ago. When they first brought out San Francisco parking meters that you could pay with a card, the way they were programmed is the app would ask the card if you had money, and the card would say yes. So all you had to do was make a modified card that always said yes, and it would approve your payment. And this kind of mistake has happened a great many times. It also happened to the first generation of encrypted thumb drives. You'd plug in the USB drive, and it would run an app which made you log in, and it would only let you see what was on the drive if you logged in. But if you just plugged it into a Linux machine, it couldn't run the app, and you would just directly access the data on the disk because it was not encrypted. It was just behind a pop-up app that didn't really need to run. So all you had to do is prevent that app from running, and the data on the hard drive was available. This kind of thing happens a lot. People put up a barrier, but it isn't a strong barrier. There's a way to just go around the barrier and get to the unsecured object behind it. This is called IDOR, Insecure Direct Object Access, and it happens all the time. All right. And so there were vulnerable broadcast receivers in the Android code base that would allow any app to initiate and terminate phone calls on really old versions of Android. So even Google made this mistake. It's extremely common, and as I've mentioned many times, it seems to be that many companies have unprotected API calls now. They have API calls coming from apps on phones and other web apps, and some of them they forget to verify that you're really the administrator or something. This happens a lot. All right, so you can listen to intents. You can, in principle, receive broadcast intents. They're going out there. There are signals inside the operating system, and if you don't require permission to receive the intent, you can sniff them. So your intent might include secrets. If you decide it's not okay to just say the user logged in, you might pass the username and PIN here with it. In that case, there's information in the intent, and so you can sniff it. But just if you have Drozer, which is this agent that comes with the pen testing I'm not using anymore, you can do a broadcast sniff, but you can do it without Drozer by just looking in the log, grep for intents, because intents are typically logged. And then you'll just see these intents go by. All right. There are also some secret codes. This is kind of fun. There are special codes on the keypad that do things. And there was a scanner in Drozer to find the secret codes. And these are not very secret. There's ways to find them. There's even online lists of them. So here's one that worked for a secret code here was this, which I think would just take you to a settings, but it didn't work in the Android Studio emulator. I think it worked in a Genymotion emulator though. That would open this testing page. It lets you create new contact, test phone information and such. And there were other ones that did nastier things. There was one that would remotely wipe the device to factory reset on Samsung devices, and therefore you could invoke it from a web page. So you could make a web page where when you go to the web page, it will open this iframe with a tel prefix, and that will automatically dial this telephone number and wipe your phone. So that's pretty nasty. And here's the kind of code you'd have on the web page to do that. So that's another bad thing that can happen to you, I think. So let's take a look at a Kahoot. All right. I do have a Kahoot for this stuff. All right. And they've changed things again. All right. 128. 7B should be somewhere on this list. There it is. All right. Give it a try. All right, so which one will make a screen pop up and can be launched from Drozer? All right, these are exported activities. The point is Drozer installs on the app like malware. It's an agent you can use, and you essentially get a non-root privilege account. So you're not root, so the only thing you can launch is exported activities. All right. Those are ones that should be available to other users on the device, which is what you'll be if you're launching it from another app. All right. All right. So which item may be vulnerable to SQL injection from another app on the phone, like Drozer? be an exported content provider. Content providers are the databases that are subject to SQL injection, and since you're not root, it would have to be an exported content provider. All right? All right. So what Samsung bug lets you do privilege escalation? Exported service. There was a service that let you copy files and paste them somewhere else. All right. All right. And what component can perform intent sniffing? That's a broadcast receiver, as you'd imagine. You receive intents that are flying out there, going to every app, trying to find an app that can use it. All right, fair enough.